The dark stream, the cosmic enigma pulling galaxies beyond the visible.
In 2008, a team of astronomers led by Alexander Kashlinsky of NASA's Goddard Space Flight Center made a surprising discovery while analyzing data from the Wilkinson Microwave Anisotropy Probe, WMAP, satellite.
They identified an unexpected collective movement in hundreds of distant galaxy clusters, something that didn't fit the predictions of traditional cosmological models. Dubbed the dark stream, this phenomenon reveals that entire galaxy clusters are moving at high speed toward a specific region of the sky, as if drawn by a gravitational force from something beyond the observable universe. The dark stream was detected thanks to a subtle effect called the kinematic Sunyaev-Zel'dovich effect. Hot.
The results were impressive. The clusters are moving at nearly 3.2 million kilometers per hour, about 2 million miles per hour, toward an area of approximately 20 degrees in the sky, located between the constellations Centaurus and Vela. The most intriguing aspect is that this flow doesn't diminish with distance, as would be expected if it were caused solely by visible matter within our universe. On the contrary, it remains constant for billions of light-years, suggesting that the distribution of matter as we know it simply cannot explain what is happening. We never expected to find something like this, Kashlinsky stated at the time. 5 years later, in 2013, the same team published even more surprising results. Using more precise data from WMAP, the 5-year mission, and doubling the number of clusters analyzed, they were able to trace the dark flow to twice the original distance, reaching regions about 2.5 billion light-years from Earth. The movement continues to point in the same general direction, now associated with the constellations Centaurus and Hydra, and persists with the same intensity. The team, which included researchers such as Fernando Atrio Barandella, Harold Ebeling, and Alastair Edge, divided the clusters into slices of different distances and confirmed that the pattern repeats consistently. The brightest clusters in X-rays, those with the most hot gas, showed the strongest effect, reinforcing that the signal was not mere statistical noise.
This persistence of the dark flow challenges conventional theories. According to cosmologists, the cosmic microwave background represents the frame of reference of the universe. In relation to it, there should be no preferential large-scale movement. However, what is observed is exactly the opposite. The most plausible explanation, according to the researchers, refers to the period of cosmic inflation, that hyperrapid expansion that the universe experienced shortly after the Big Bang. If inflation really occurred, the universe we see is only a small part of a much larger cosmos. Matter that was pushed far beyond our observable horizon could be exerting a gravitational pull on our neighborhood, creating this mysterious flow. Scientists compare the dark flow to other great mysteries, such as dark matter and dark energy. The distribution of matter in the observed universe cannot explain this movement, Kashlinsky emphasizes. The discovery opens a fascinating window to explore the state of the cosmos even before inflation. Although controversial and not yet confirmed by all models, the dark stream continues to be investigated with data from missions such as Planck, from the European Space Agency, which maps the microwave background with even greater precision.
To this day, the phenomenon intrigues the scientific community because it suggests that the visible universe is only the tip of a much larger cosmic iceberg. What pulls these galaxy clusters together may be hidden in regions we will never be able to see directly, but whose effects we feel through gravity. Future studies, with larger catalogs of clusters and more refined analyses of the hot gas, promise to reduce uncertainties and perhaps reveal whether the dark stream is indeed a sign of a multiverse or something even more extraordinary. For now, it remains a humble reminder that the cosmos holds profound secrets, waiting to be deciphered by the next generations of telescopes and space observatories.